And good afternoon to all of you. So I welcome you into the room A, session A4. And this session is going to be moderated by the session chair, Mohamed Ali. So before calling him, I just give the brief introductions about the Mohamed Ali. He is a professor at Mechanical Engineering Department, College of Engineering, King Saud University. And he published more than 150 research articles and at the international journals, and also he have around 50 proceedings and seminars, scientific awards, and also he have a patent in related field. So without delay, I call the Prof. Mohamed Ali to please come on the stage and take the session chair. So you can invite by yourself. Okay. So because we make the session chair who is also the presenter. So first he is going to present his work and then he will take the charge.
Okay, thank you.
Yes. You want the mic? Or?
I will need a mic, yeah, sure. Okay, good afternoon. Today I'm going to talk to you about the new novel thermal insulation material made from date palm tree surface fibers and palm tree leaves. Okay, and this hybrid with some other material, as we'll see, like the apple of sodom fibers and wheat straw fiber. As we see here, this is the palm tree surface fiber, and this is the palm tree leaves. So we're going to test both of them for insulation, to be as an insulation material, and also we're going to test them to be sound absorbing materials. And also, we have done some samples in hybrid between the palm tree surface fiber and apple of sodom fiber, and between the leaves and the wheat straw fibers. So as we see, this is the palm tree surface fiber, which I'm talking about, and the leaves, which is the leaves from the grading here, okay, which is like this, okay. So I'm gonna test them, and I'm gonna use them as a hybrid with apple of sodom fiber and with wheat straw fiber. Because apple of sodom fiber, it has very low thermal conductivity. So when we made it hybrid with the palm tree surface fiber or with the palm tree leaves, it gave it more strength. For those of you who are not familiar with the palm tree surface fiber, so the palm tree surface fiber comes, the scientific name of it is Calotropis brothera, and this is the tree. This is the fruit of the tree. It's like the mango fruit, and this is the fruit at its mature time. It's open up, and this brown seed. So we incubate it and take off the brown seed, and this is the white fibers which we are interested in, okay? So this is what we call the apple of sodom fiber. It grows up in desert areas by itself. It doesn't need so much assistance, okay? Its root goes down 5 meters, so it can get the water which it needs. In fact, in Arabic, they call it al-ushar or al-ush, and the slang language for it, in Arabic also, they call it shajrat al-shaitan. Why? Because when it cuts a little piece of it, there is a little liquid comes out of it. It's like milk. It can make irritation, and you can hurt your eyes. So in order, when I go to collect it, I use to have goggles and gloves to keep my hands. Okay, and in medicine they use it to make some band-aids, okay, and some antibiotics. This is how the process goes. We collect the fibers, and this is the mold. We put it in the mold, okay, press it, and then move it to the oven, okay, and then after completely dry, we move it to the heat flow meter to measure the thermal conductivity. And these are some samples made only from palm tree surface fiber, just as a little introduction, okay? And we can make it like a cylindrical shape to can roll it about the any pipe or something like that, okay? This is the thermal conductivity, and as we see here, this is the thermal conductivity of the apple of sodium fiber. It's very close to the ASME standard, so it's very good. Here is two samples. One is high density, higher, but this is low density. And this is another two samples which are very close to the ASME standard. So it has a very good thermal conductivity coefficient. That's why I hybridate with the palm tree surface fiber and with the pineapple palm tree leaves. Okay, this is the sound. We measure the sound absorption coefficient to see its ability to absorb the sound. The higher density one, it's good at high frequency, and the low density one, it's good at low frequency. The other one, it's good at high frequency. This is the fiber. It's very silky. It's like hair. So the size of the fiber diameter between 5.56 up to 20 micrometers. This is the thermal degradation of the apple of sodium fiber. Okay, it's stable up to 222 degrees centigrade. Okay, and this is the at 50 weight decreased by 50%. Okay, at about 300. Now we start about our major talk, which is the palm tree surface fiber. We have done 4 samples, and we used cornstarch as a binder. So everything is natural. We are not using any chemical treatment, no chemical treatment at all. We just use cornstarch solution with different concentrations, and we have done 4 samples with different densities. Okay, A, B, C, and D. Okay, and this is the percentage of the polymerized fibers, polymerized cornstarch in the fiber. Okay, and the thickness. This is one sample of it. Okay, it's using the cornstarch as a binder. Okay, and the thermal conductivity around 0.05. Okay. So these 4 samples with different densities, and this is the thermal conductivity. And as we see here, when you use the palm tree surface fibers alone, it has a thermal conductivity between 0.045 up to 0.065, and of course it increases as the density increases, and it's away from the ASTM standard. That's why when we compare this to the palm tree, to the apple of sodium fiber, the one for apple of sodium fiber was close to ASTM standard. That's why our next step is to make a hybrid between 2 of them to make the producing thermal conductivity to be lower than this. And this is the variation of the thermal conductivity with the density at various temperature. Of course, it increases as the temperature increases, and for fixed temperature, it increases as the density increases. This is the SIM of the surface fiber, the diameter between 12 micrometer up to 55 micrometer for palmetry surface fibers. This is the TGA for that, which shows that the palmetry surface fiber is stable up to about 232, where it only loses 8.5%, which it could be related to the water vapor vibrated at that range. And this is the degradation temperature at 50% degree degradation at about 364. So if you compare this, it's very good to be used as an insulation since it is stable up to this temperature. And this is the derivative, which shows that the major degradation occurs in these two temperature limits. Now we turn your attention to the hybrid ones. These hybrid ones with apple of sodium fiber, okay? So we expect to lower the thermal conductivity and to make it more strength. Okay, sample of this is this one, okay? The white here is the palmetry. This is from sandwich, okay? Apple of sodium fiber in between, and from here and here, there is sandwich between palmetry surface fiber. And we have different sample, different composition, different percentage of the apple of sodium fiber with the palmetry surface fiber. The first one, it's a pure palmetry surface fiber. This one is a percentage, different percentage, and all of them, they are using cornstarch as a binder. This is the fiber of the palmetry, of the apple of sodium fiber, and this one for the palmetry. So this hybrid, it's between these two with different composition according to this table. Okay, this another two sample, and this sample 5 and 7 we use just for comparison with adhesive as another binder for this sample, and here we use white cement as another binder, just for comparison between different binder and what its effect on the thermal conductivity. As we see here, this is the samples 1, 2, 3, and 4. Sample number 1, it's a pure palmetry surface fiber. No, it's not hybrid with any, so it's only by itself, but it's with cornstarch as a binder. Sample 2, apple of sodium plus palmetry surface fiber plus the cornstarch. The percentage of cornstarch is 28. And as we see, when we add the apple of sodium fiber to the palmetry surface fiber, we notice that the reduction, a clear reduction in the thermal conductivity coefficient from pure palmetry surface fiber to the first hybrid. And as we increase the percentage of apple of sodium fiber to the palmetry surface fiber, we get more decrease, more enhancement in the thermal conductivity coefficient, as we see in number 3 and in number 4. Getting more closer to the ASME standard. These two samples to see the effect of thermal conductivity between sample number 5, okay, which use the wood adhesive as a binder, not cornstarch. And the number 7, it used white cement. And it's clear that the wood adhesive give more enhancement to the thermal conductivity coefficient, and they made it close to the ASTM standard. Okay? Here is a comparison between the three thermal conductivity corresponding to the three samples. One used the wood adhesive, okay? This is used cornstarch, which is number 4. This is white cement, number 7, and this one is using the wood adhesive. The best of them is the wood adhesive as a binder. It's very close to the ASME standard, okay? Of course, this related to the pure thermal conductivity of the cornstarch is very high, so when you add it to the fibers, it makes it higher. But it is, here we test the sound absorption coefficient for the hybrid ones. And as we see here for this sample number 2, apple of Sona plus palm Z, using the cornstarch, we tested from both sides, A and B, which is this sample. So this is the sample, okay? And this is the palm tree surface fiber from both sides sandwich, and the one in the middle is apple of sodium. Oh. 50 minutes, I'm fighting. Oh, yeah, 30 minutes, I'm fighting to speak. Okay? So this is the sound, and as we see, most of them, they have better sound absorption. It's well known that when sound absorption is 1, it's complete absorption. When sound absorption is 0, no absorbent. Okay, this is the table to show the other study. Used the date palm leaves, okay, with the other wheat straw fiber as a loose sample or a bound sample. Some of them using cornstarch, some of them using the wood adhesive as a binder. These are the samples, different samples. These are the loose, these are the bound with only the binder cornstarch, and this with cornstarch hybrid. All these are the hybrid with wheat straw. This shows the diameter of the wheat, of the straw fibers, okay? 1.28 millimeter minimum. And this to show the multicellular of the wheat straw, shows the big diameter and the multicellular diameter of the porous ones. This is the sum of the date palm leaves, okay? And this is the thickness of the leaves, okay? Thickness of the leaves. This is the TGA for that. It also shows that the date palm leaf are stable up to 213. It's only lose 10%, and the 50% degradation occurred at 356, okay? And degradation at 70% at 503. So it means it is stable, so it can be used as thermal insulation. This is the moisture content, okay, experiment we have done to see how much is the fiber can absorb water. So it's a moisture content about only 5%. This is the thermal conductivity coefficient. As you see here, the loose fiber. So the loose fiber, of course, has a lower thermal conductivity, and when you add the binder, so it increased. And here it shows when we use this to show the effect of moisture on the palm tree leaves. If the palm tree is not dry enough, so it means it has a little water, so it will give a high thermal conductivity, like this one. When we oven dried it, we get this one. So it's very good when it's dry. Okay, and these are the thermal conductivity for all the hybrid sample, and all of them below 0.065. So it's very good to be used as a thermal insulation. This is the sound absorption coefficient for the hybrid one using the palm tree leaves. Okay, as we see, most of them in this range, which is a communication range of sound, so it is very good at most frequency. It's higher than 0.5 for most samples. This is the 3-point bending, okay, has been done for the hybrid sample, and this is the Young's modulus and the stress and the strain using the universal testing machine. So, conclusion, new natural insulating material are described and developed from different agrofibers such as date palm leaf, palm tree surface fiber, and their hybrid with wheat straw fiber and apple of sodom fiber. Thermal conductivity of loose fiber, bound fibers, and hybrid ones are less than 0.07, which is very good to be considered for sound and insulation and thermal insulation. The developed sample have good sound absorption coefficient. The both DBL and palm tree surface fiber are stable at high temperature, greater than 200. They are eco-friendly insulating material, natural, safe, no harmful on human being. For more details, these are some of the publications. Acknowledgement, okay. The apple of sodom fiber was sponsored by this, okay, and also we acknowledge the Dean Chair of Scientific Research, and these are my research teams. Thank you for your attention.
Thank you, Prof. Ali, for giving a very good information about, especially for the insulation board, you know, from the date palm. So now the floor is open for the questions. If anybody have anything to ask, please, because we have limited time. Any questions? If no questions, yeah, ask. Can you give the mic to him?
Good morning, sir. I would like, thanks for excellent presentation. I would like to ask to you, what's about the void contents in your material?
Void content. Yeah. Void content.
Void content, yes.
Okay. Well, we didn't study the void content, but you know, when you use a loose sample, it has a lot of void content, and this void content, it has a small diameter. That's why we show the thermal conductivity is very low. When we add the binder, this void porous, it filled with, most of them filled with the binder. That's why we found the thermal conductivity increased, okay? So it's good to have a void porous medium as long as, because air will be inside, and the thermal conductivity of air is about 0.03, okay, as long as heat is conducted by conduction. So, but if this void is large, so it will be conducted by convection, and this will increase the thermal conductivity.
One question more, if there is, otherwise we can start at the presenter. Okay, I think no questions, so you take the charge and start.
Okay. Hmm.